Hi guys, my name is Kevin and I am the SI for Dr. Dingwall's section of Biochem 110B. And today we'll be going over a little bit of fatty acids and how they're activated and their mechanism into getting to the mitochondria. Okay, so let's get started. So the first question is with regards to fatty acid activation. So it's asking us what our reactant is. And in this case, our reactant is going to be a fatty acid. Our product is going to be an acyl-CoA. And the enzyme required for this is going to be an acyl-CoA synthetase. And in this case, we're going to be requiring 2 ATP or 2 ATP equivalents. And where does this occur? It occurs in the cytoplasm. So to kind of reverse a little bit, for the reactant being a fatty acid, for this class specifically, you don't have to know what fatty acid this reactant is. It can just be any general fatty acid. But the 4 fatty acids that you need to know are specified in her lectures. But in this case, we're just going to be talking about a general fatty acid. So an example could be one that simply looks like this, okay? So if we have this fatty acid, this is going to be our reactant. And another thing we're going to be requiring is a CoAsh, okay? So we're going to be adding an AMP onto our reactant. Sorry about that. And it's going to look something like this, okay? Once we have added this AMP, this makes this molecule have a better leaving group. That is the reasoning behind adding this AMP molecule, right? Once we've added this AMP molecule, we can now easier than with this carboxylate ion right here, we can easily add that CoA and make this into, let's see if I can draw this out, into something that looks like this. Okay, so this is the CoA. So first we start with this carboxylate ion, then we jump to an AMP, and then we go to a CoA. All right. Now for the second part, we're just looking for 2 steps. So step 1 and step 2. What is happening? So kind of going back to what I was telling you, this drawing that we've made right here. So the first step, we're going to be adding an ATP, or in this case, it seems like we're adding an ATP, but we're removing a pyrophosphate. That's what PPI stands for. So right, this is this step. We are inserting an ATP in here, but we're also getting out a PPI or a pyrophosphate, and we're inserting this AMP. The second step is going to be, we're going to be adding a CoAsh or a CoA, right? And then we're going to be removing an AMP. So this is where the AMP goes out, but we're putting in a CoAsh, right? And that is the purpose of fatty acid activation, okay? Now we can move on to the beginning of this question. So the first part says, fill in the following table with regards to the blank shuttle. In this case, we're going to be talking about the carnitine shuttle, and we're going to be going over all 3 enzymes, all 3 processes, and all 3 locations, right? So for this video, we'll just go over the first one, and I'll leave it to you guys to fill out the last 2 boxes. Or if you want, you can come to session, get access to these worksheets, and we can work through it together. All right. So for the first one, the first enzyme involved in this carnitine shuttle is going to be called carnitine acyl transferase 1, or CAT1. For this class, remember that when you're doing your exams, write out the full name of the enzyme, and then after that point, you can start using the abbreviation. So first, write out carnitine acyltransferase 1, and from that point on, you can start using CAT1 as an abbreviation instead of having to write out the whole name, right? So what is happening here? What is happening that this enzyme is needed, okay? So in this case, we're going to be transferring the acyl group to carnitine, right? To a carnitine molecule, okay? So in order for this fatty acyl CoA to get into the mitochondria, we have to replace that CoA with a carnitine, and then later on, you guys will see that that CoA is put on in the matrix, okay? And another key thing to note, you should be able to tell what molecule actually inhibits this first step. That is key to knowing the regulation behind this shuttle. All right. So now we'll move on to the last part, the location, the where. So where is this process happening? So we're starting out in the cytosol and basically moving into the intermembrane space. Okay. And something that you'll see through this little table is it'll go something like this. I'll give you a hint for this one. It happens in the matrix. And then from here, or it actually occurs from the IMS to the matrix. And then you'll see this again, and then we'll be in the matrix. So it's kind of like a zigzag. So that's why I like to create these tables, because it kind of helps you see the information in a different way. All right. So I'll leave the rest of the table up to you guys. If you have any questions, my email is in the description below. And if you guys would like to come to sessions, my sessions are Tuesdays and Thursdays from 3 to 4 p.m. Okay. Have a great day.